graphs are pictures. Right? And we all know that pictures are worth 1,000 words. It's much more efficient, much easier to understand how different variables interact with each other and how models work when we're comfortable with graphs. So we're going to look at a lot of graphs, and we're going to look at percentage changes of a lot of variables. So in this section, we're going to try to look at some tools and some graphs that you're going to want to be comfortable with. Now, there are lots of different types of graphs. Suppose we're trying to graph a single variable. Well, we could do that in many ways. One, we could look at a pie chart. Pie charts look at one variable and how it might be split up or distributed between different types of that variable. In this example, we're looking at the types of recorded music sold in the United States. This is from 2004. Right? So it could be rock and roll, rap or hip hop, and in this pie chart we can see that rock and roll was 24% of recorded music sold in the United States in 2004. Country was 13%. And so one way of looking at a single variable and finding out information about it is from a pie chart. Another way is looking at a bar graph. A bar graph would compare a variable and different types of that variable by looking at the height of those bars. Here we're looking at U.S. export sales of copyrighted products. And so this bar over here is the amount of newspapers, books, and periodicals that were sold in 2002 as U.S. export sales. So if we want to compare this bar to this bar, which is computer software, we can see that there was far more computer software exported from the United States than there were newspaper, books, and periodicals. Another way of looking at a single variable is a time series graph. Here we're looking at total industry sales of some industry over time, and we can look at time on the horizontal axis, and we can see how that variable changed over time by looking at the time series graph. Now, it's important to understand how these graphs look. In fact, this graph is the same graph as this graph. The difference is the scale of the vertical axis. You can notice the one here on the left goes from 0 to $14 billion. And this one, there's a truncation in the axis. The vertical axis goes basically from 10 to 14. So it looks like this variable goes up and down more than this variable, but in fact they're the same variable, they just have a different scale. So when you're looking at a graph, and particularly a time series graph, you want to look at what the scale of the vertical axis is. Now, a lot of what we look at in economics are two variable graphs. Right? So there are several variables of the basic elements of a two variable graph. And any point on a two variable graph represents a combination of these two variables. We have the horizontal axis, also known as the x-axis, and we have the vertical axis, also known as the y-axis. The distance along the horizontal axis represents some amount of a variable, whichever variable is being plotted along the horizontal axis. The distance up along the vertical axis represents some amount of another variable, that variable which is on the vertical axis. So if we look at this point A, we can say at point A, this is a representation of 10 units of whatever's on the horizontal axis and 13 units of whatever's on the vertical axis. One of the large or most prevalent graphs we're going to look in economics is supply and demand. In supply and demand, we generally have the quantity of a good or a service on the horizontal axis and the price of a good or service on the vertical axis. So in this graph, if those were the variables, then the point A would represent a quantity of 10 units and a price of 13 units. Now, any other point on this graph will represent some different combination. Suppose we looked at another point on the graph right here. Well, this would represent some amount of the variable on the horizontal axis, and here we're looking at quantity if this is a supply and demand graph, and some other amount of the variable on the vertical axis. And again, here we're looking at the price level. And what we would know about this point is there's a lower price and a lower quantity. So any point anywhere on this graph is going to represent some combination of quantity and price. So we're going to look at lots of what are called linear graphs. A linear graph is any line which has a constant slope, or is a straight line. In this graph, we're looking at the relationship between the hours worked per week and the income earned per week. Now there's a number of things that you should notice about this type of a graph. Well, first of all, this is a positive relationship, meaning an increase in the hours worked increases your income. You know that because this graph points upward. And if we compared point B to point C, at point C there are more hours worked than at point B, and there's more income earned than there is at point B. Right? This is up and has an upward sloping curve. Now the slope of a curve is very important to understand. The slope of a curve tells you what the relationship between the variable on the horizontal axis and the variable on the vertical axis is. And one way to think about the slope of a curve is to look at the formula, which is the rise over the run when looking at two different points on that curve. Well, what's the rise? Suppose I'm going from point B to point C. The rise is how much you've gone up, or how much higher is point C. Well, we can look at that. It's 80 units of whatever's on the vertical axis. It's 200 minus 120. So the rise is going to be equal to 80. The run is the change of the horizontal axis, or how much you've moved horizontally. Right? So the rise is the vertical change. The run is the horizontal change. So when I move from point B to point C, I go from 10 to 20, so the run is the change, or 20 minus 10, or 10 units of what's on the horizontal axis. So when I calculate the slope, I can look at the rise divided by the run, and that gives me 80 over 10, or 8. So the slope is the change in the variable on the vertical axis divided by the change in the variable on the horizontal axis. And if we're graphing two variables, we can either have a positive relationship or a negative relationship. The positive relationship means that the two variables move in the same direction, like we saw in our last graph, and we would have an upward sloping curve. A negative relationship is one in which the two variables move in the opposite directions, and so we would have a downward sloping curve, because when one variable goes up, the other variable goes down. Another thing we want to know about curves and graphs is what makes the curves shift versus what means a movement along a curve. Now there's a pretty simple rule of thumb when looking at this, and it's going to be very important for you to understand it and remember it as we move through the course. There are two variables in this graph. Everything else is held constant. Right? The hours worked per week and income per week. Those are the two variables that we're looking at when we look at this curve. If either of those variables changes, we have a movement along the curve. So if we are at point B and we decide to work more hours, that would be represented by a movement along the curve to point C. And what we would see is income per week would rise. But it rose because we decided to work more hours. Now if something else changes, for example, suppose your allowance were to change, or the amount of money you get even if you don't work any hours, right? That's the vertical intercept. It's the value of income for 0 hours worked. That's what we call the vertical intercept. Now if that changes, so suppose instead of getting $40 even if you don't work, it moves up to $90 even if you don't work, well that means your income rises even if hours worked per week doesn't change. Well, that can only happen if the curve shifts. So if a variable on one of the axes changes, you move along the curve. If another variable that impacts income changes, then you have to shift the curve. And if we wanted to graph a negative relationship, as we saw, this would be the two variables moving in the opposite direction. Then we would have a downward sloping curve, and the result of that is a negative slope. We can also look at nonlinear relationships. Linear relationship was that straight line curve. Well, this is not a straight line, it's a curved curve. This is what's called a nonlinear relationship. This happens when, suppose we look at the amount of time you study for an exam and the points on exam that you earn on the exam. Well, the first couple hours that you spend studying for an exam have a significant impact on the number of points you earn. So if you decide to study a second hour instead of 1 hour, it's going to increase your production, or the points on your exam, by 4 points. Well, once you've already studied for 8 hours, you've already learned a good deal of the subject, and if you increase another hour, then the impact on your points might not be as large as it was for the first couple of hours. This would be a nonlinear curve, because the effect of study time on points is not constant as you increase your study time. And finally, we want to be very adept at computing percentage changes. Right? So when we look at two variables, or one variable and two values of that variable, if we want to calculate the percentage change, we need to look at the new value of a variable minus its initial value. An example we might look at is the price of a good or a service. So suppose we have the price in 2010 and the price in 2011. And we want to look at the percentage change of those prices. Well, the initial value of the price is 2010, so it's going to go into the formula here and here. And the new value of the variable is the price in 2011, and you plug that in here. So to compute the percentage change in the price of a good or a service from 2010 to 2011, you take the price from 2010 and put it in where the initial values go. And you take the price of 2011 and put it in where the new value goes. So you have the change in the price, or the change in the variable, divided by the initial value of that variable. And you multiply it times 100 to get it to be a percentage change. You're also going to want to be very good at using equations to compute missing values. Remember, when we looked at the slope of the curve for hours worked and income, the slope was equal to the change in income divided by the change in work hours. Now suppose you don't know the change in income, but you do know work hours and slope. Well, since we know this equation is correct, we can alter and solve for one of the other variables as long as we know two of them. So suppose we look at this first equation and we multiply both sides by the change in work hours. Well, if that's the case, then the change in work hours on the right-hand side will cancel each other out, and we'll have it left on the left-hand side, and we get an equation that looks like this. The change in work hours times the slope is equal to the change in income. So if you have an equation with three variables in it, and you know any two of them, you can solve for the third by looking at straightforward algebra to solve for the variable that you don't know.